I'm glad I'm glad so many of you came out of church to be here this morning. I know it's difficult. This morning I want to talk about something fairly serious, security testing, because it's pretty much generally worldwide done completely piss poor. So put on your sober faces, wake up a little bit. I may even point at some of you and ask you questions. And if you're not awake or you don't respond, I'll ask you to leave. It's that important. My name is Herzog. I'm the managing director of Ssl, which is an open source research, security, collaborative community. Basically, I manage all the projects. I began by being the creator of the FOSDEM, and I'm still the main developer of the FOSDEM. Yes, the OSSTMM, Open Source Security Testing Methodology Manual, which the British started calling the FOSDEM, and it works for me. So yeah, I run Ssl as the managing director, mostly the volunteers, the groups, not the operations. We have the FOSDEM, we have Hacker High School, we have business integrity testing. We even are doing open trusted computing as part of the Trusted Computing Consortium here in Europe with HP, IBM, SUSE, big group trying to bring transparency to trusted computing, which is actually very, very close right now. And even we have groups like Infineon who make the Trusted Platform module as part of it. Goals and ambitions, well, you want, I'll be talking throughout this talk about my lofty goals and ideals, which is basically to make security better, to make it better how we test security. And that's really important to understand because we are all dependent on somebody else doing their job right, no matter what we do. Whether we drive a car, we have to make sure that the guy who put the tires on the car wasn't asleep that day. We are so dependent on what everybody else does that my job, as I see it, and my mission, my goal, is to make sure that security is done right and that it's not my fault for not telling people how to do it right. I love the eureka moment. I love it when an idea works, when things come together. And I hate malicious ignorance. I really hate when people say, well, I didn't do it because I didn't know. And if it's your job, then it's your job to know. Unfortunately, there's nothing like malpractice in the security field. So, as far as I see in security, any type of ignorance, if you're a professional, is malicious. So, a quick overview of today. Security testing is complicated. Verification is always something you should do yourself. If you rely on tools, you're probably a fool. Okay, that rhymes. And there is a trick to quickly sizing up security, and I'll teach that to you if you're nice to me. Make it cool. The problem is that testing security is innate, and so is protecting. So whenever we build and develop something, oh sure, laugh at the speaker. Okay. Basically, anything that we want to secure is innate. As developers, we build things, but when we build things, we build them so that they work the way we want them to. We have an idea of how they're going to work. And generally, any failure in how they work is a problem. It's an issue. And even though we like to think of security as threats, people attacking, it's also as simple as building a wall so that the wall doesn't fall over while you build it. Okay, we'll try this again. So when we build the wall, we obviously don't want the wall to fall over. You know what? I'm going to talk really loud. How's that? There you go. Your tool's failing on you. So when we build this wall, we take a lot of pride in the wall that we build. We're happy with that wall. And the last thing we want to do is test it by pushing it over. Because what if we're wrong and the wall falls over? We have to build the whole damn thing up again. So security is innate. While we build that wall, we are thinking that wall has to stay up. Yet, we are also afraid to test it because we don't want the consequences of what happens when it falls down. More work. So as developers, builders, we have a problem with testing our own stuff. But then again, in many instances, they ask the developers to test their own things, which is part of the problem. Other issues are interviews are biased, people's knowledge of security is very subjective. I don't know. And most of the tools and the procedures, best practices, are built to conform to certain rules of the game. The problem is, the real world doesn't conform to rules. There is no canned analysis. Because then you find that what the tools will do is discard responses it receives because it wasn't expecting it. The truth is, security is a humbling experience. If you're in security, you will be constantly, consistently humble. You cannot be arrogant and be in security. It just doesn't work. Okay? You build a better mousetrap, someone makes a better mouse. You build something foolproof, someone makes a better fool. That's just how it works. Now, a lot of people like to say the main issue of security is risk. Risk is not security. Security is protection. Risk is a statistics game. You can play that game if you want or not, but it's very subjective. This one? I'm actually going to leave it here somehow, so I don't have to use it. And it uses me. There's a new thing in medicine called evidence-based medicine. And the whole point is actually it came out in the 90s, it's growing in popularity, and it's about having the doctors actually use science to diagnose people. Yeah, this is new. And you'll actually see it starting to come out in more and more magazines. It's a big deal. And the reason why is because obviously we know that certain medicines affect you. They have side effects. They may even cause kidney, liver damage in addition to healing you. So now with this evidence-based, they're looking at maximizing your lifespan and quality of life. So, for instance, they may not give you a drug because your problem, your cancer, your disease may not have an immediate effect. For example, if you're 70 years old, there's a good chance you'll probably die before something like prostate cancer actually kills you, which has a long-term effect. So they start looking at these things and your quality of life. And so I like to think of this as evidence-based security, where you're actually looking at the big picture. The only problem is it doesn't work in emergencies. It doesn't apply to everyone. And the biggest flaw with actually using science for security is the CYK problem. Cover your ass. People don't buy it. People would rather buy a big brand to say, hey, I did what I could. I bought IBM, I bought HP, I bought Ernst & Young. They came in, they did their job, I'm clean. Okay? So the only people who actually buy into the scientific method, who buy into ISACOM, who come around, are the people who actually need security and not compliance. So if you actually need to secure something and not just have a paper that says you're secure, you're going to be looking for this methodology. Quick quiz. You've seen in the sky, I assume here in Belgium you can see in the sky, geese or ducks flying overhead, and they fly in this V pattern. You all seen that? Hands, wake up. You've seen it? Yes, no? Okay. And one line of ducks is always longer than the other. You know why that is?
Someone shot the other ducks.
And this is the problem with security today. The answer is, there's more ducks in it. We think we know what we're doing, and we fail to analyze because we are subjective. We need to test more. We don't know why there are more ducks in it, okay? But we do know that there's more ducks. But we answer the question of why is it longer? Because there are more ducks in it. And this is a problem with analysis and security. And we're going to talk about that, hopefully if we have time. Basically, as human beings, we are subjective. Our minds work in a certain way where we apply weight to different risks, depending on how important it is to us. We're definitely not objective about it. So, we needed to look at something new in the way we perceive and define security. And we did this in the FOSDEM, which is under copyleft, and the methodology is under the OML, the Open Methodology License, something we had to create because a methodology cannot be copyrighted. A methodology is considered a trade secret. So we designed a license for an open trade secret. Basically, the idea is that somebody else can't say it's our trade secret. So what do we do new in the FOSDEM 3? Well, we want to categorize security into calculable components, clear definitions, security metrics. We started adding things about test errors, test types, vulnerability classifications, blah, blah, blah. We wanted it to be practical for the auditor as well as the developer. So the developer would be able to quickly size up security in what they're developing while they're developing it without needing to resort to some huge manual or checklist, which is often dated or wrong. And we wanted to get rid of best practices. So the FOSDEM 3 is completely new research. It's actually been researched, which is why it's taken so long. And for all those people who say, hey, why does it take 4 years for the FOSDEM to come out? I want to ask you, who else has security metrics that actually work? Yeah. They've been working on it much longer than us. Okay, let's look at a security test defined. What is a security test? Well, the first thing we want to do is we want to measure operations. We want to know how something actually works. If we don't know how it works, we can't tell you how it's not working right. So it's important to actually understand how something works. Then, we're able to apply measures, security measures, which are actually a good fit. From there, once we actually know how it works, what security measures are there, then we can start our risk analysis. But we completely keep bias and risk out of the FOSDEM. There's only one place where it even shows up a little bit, and that's where you self-assess your own errors. And we do that for two reasons. One, because it helps you learn more, and two, it helps your client or whoever you are testing or auditing understand the difficulty level of the job you just did. It's not an insult to you if you have a lot of errors, because it could be the network that you were testing produced a lot of errors. It could be uncooperative sysadmins. And the beauty of it is that you actually get a report that you fill out at the end where you explain these things. So you not only say what you test, but most importantly what you did not test. So later, if another company comes along and does an audit, you could actually compare the two for thoroughness. When we look at this testing, we found that on a fundamental level, it was done wrong in a lot of places. We actually had the community push us to make a certification. And the reason why was that way they could hire people that they knew could hit the ground running, that they could work immediately, and they would know what to do.
So we ended up making 2 certifications for that in testing and analysis, the OPST and the OPSA. And just to give you a little bit of an idea of how they work, for something like the OPST, you'll have to define things like, where's the physical location of a web server over the internet? If you have 3 different services on a server returning 3 different TTLs during your port scan, what's actually happening? What kind of increased data do you need to collect in order to come up with a better analysis? And even little things like you do a port scan and port 80 comes back that it's open. But then when you telnet to it, you don't get a response. Anybody want to explain why that one? Since we have one in it. Number 3. Go ahead. Transparent proxy. Brilliant. Good idea. That's one way to do it. How would you check? What other tests would you need to do? Okay. When would you consider yourself done though? How many more would you test before you decided that you've tested enough? What's the magic number? No, it could be as simple as looking at the TTLs. You're going to have a shorter TTLs because it's closer to you. That's one definitive test. And yes, you could make more tests and see that that's happening. That it is a coincidence. But that's how you do it. And this is what we show, how you come up with the new tests on the fly, because you're always going to have new technologies. You're always going to have new issues while you're testing. And we want people who can actually think for themselves and not just run a tool, to be able to come up with the new tests as it comes up. So we had VPNs, then we had Ssl Vpns. And I know a very large company who was looking for somebody who could security test Ssl Vpns for procurement. The problem was that the answers they always got back was, nobody's ever really tested Ssl Vpns before. And so they were doing your typical web tests. The problem was that these security experts weren't defining new tests. They were stuck with a new technology. So this is what we try to bring into people. One last thing, by the way. Telnet is not the protocol for web, so that could also be your problem. In analysis, we do the same thing. We want people to be able to hit the ground running. We want, more importantly, the people you do business with to actually understand what the heck you're talking about. So we try to teach analysis, which is actually, the OPSA is a harder class than the OPST. So we always recommend it second. But we look into things like the famous trace route. You've all done a trace route, I assume. Well, I mean, a couple of developers probably don't. But when you do a trace route, sometimes you get back the little stars. Sir, why did the stars come back? Yes, you. Firewall filtering ICMP packets. That's what you would put on the report? Sir? What was the first part, sorry?
I believe it said not returning.
The router not returning. Yeah, I see you guys. Come on, somebody give me the real answer. You get a gold star. The only thing you know is that you did not receive a response. You don't know why. See, we have this innate thing where we think we can assume based on our experiences, which is why we'll always be taken over by robots someday. And we could go on. Let's give some background information. Let me define for you what security is. It's something which protects an asset from a threat. Okay? Basically, you're actually separating the threat from the asset. So 3 common ways of doing that is, you move away from the threat. Okay, you're afraid of lightning. Your threat is for lightning, so you move inside a mountain. Okay? Your threat is terrorists, so you close all borders. Okay? You eliminate the threat, Some countries go after the threat. They decide they destroy the whole threat, and that answers the problem. I'm not going to say, I'm sure you guys can come up with an example. Or you convert the threat, which is something that was very popular back in the early days of Spain with the Spanish Inquisition. As we can see that any way that we apply security, it's usually fairly drastic. Safety, on the other hand, is where you learn to live with the threat. Basically, you want to control access, process, interactivity, or the impact of the threat. So that's where you get things like your authentication, you have people travel with IDs, all sorts of things that you want to do to lessen the threat. So, of course, if your fear is lightning, maybe you walk around in a Faraday cage. Okay? Or you cut down the trees around your house so that they can't knock over the trees and it falls through your roof and kills your family, breaks your TV. Okay? So now that we understand the difference between security and safety, which apparently the dictionaries don't seem to understand, we can actually take our concerns with how security works. Okay? So what this means is that we don't have to care what they have for security solutions, we care how it works. Okay, everyone here might be familiar with the Pci Data Requirements for Visa, MasterCard. Some of you might know that. Basically, you have these checklists. And actually, anybody who works in the government will know these checklists, or works with BS 7799 will know the checklist. And they ask you things like, are they running antivirus? When the actual question is, does antivirus even work? And I'm not saying that they update every day. I'm talking about they've got a whole slew of blacklist technologies that they're running. Blacklist technologies. And they're calling that security. By the way, antivirus is not security. Which I just said that, now that this goes on the web, well, you know that we're never going to get special funding from Symantec. So, I still sit down with them and take their money then. So basically, we minimalized operational security, or OPSEC if you're in the biz, into visibility, access, and trust. Visibility is your number of targets in the scope based on an index. Index is how you count them. Okay? By IP address, by MAC address, by person, by street address. There's ways that you count. And from a vector, from the inside, from the outside, from within one view vantage point versus another. Basically, your visibility is opportunity. If you know something is there, you can attack it. Access is your unique interaction points. Okay? So basically, any place where you can have an interactivity. It could be a service, it could be a kernel response, like for ICMP, or there's other ways of doing it, like in a physical security audit, you have doors and windows, which actually open. Those are interactivity points, as opposed to the ones that are sealed shut, which are not. And then you have trust, where the targets actually interact with each other in an open manner. Like a web server pairing a database server, or an internal help desk that will not identify the people who call if it comes from an internal number. And then you have your safety, your controls. Just take a seat. You have your Class A and your Class B. We got really clever with our labeling, so just go with me. The problem is that anytime you label anything, you make the people who don't know a damn thing get very angry about vocabulary, because people actually like to argue. Yeah, it's human nature. We like to argue. So, of course, if you label something, they're going to argue the semantics or the definition of what you label. And this is where I take a step back and I say, then change the label. Just go with the definition. I don't care what you call it. So here we have interactive and process. We're going to go through them. Your interactive controls are authentication, blacklist, whitelist, tokens, passwords, indemnification, which is to cover your ass. Basically, you take out insurance on everything. So you have an asset. You take insurance on X asset, Somebody steals it, you get big money. You don't care. Okay? Even better in data security, you have asset, somebody makes illegal copy of said asset, you still have asset, you still sell it, you get big money. Resilience. You want to be able to control how something fails so that it fails securely. It fails closed. Okay? So you go to rob a bank, you shoot the security guard, and magically he falls against the door and you can't move him. He's so big, so the door stays shut. Could happen. Okay? Firewall. Gets hit, falls over, make sure everything is closed. Subjugation. Basically, the controls are handled by the people who make the controls. So basically, you've all seen this. You go someplace, the guard gives you the paper to sign yourself in. He looks at your ID, gives it back to you. You finish signing yourself in, hand him the paper. That fails subjugation, which means he should have signed you in. Because now you could have signed anything you wanted. Do you think he's going to remember every card he looks at? And you see that everywhere, by the way. You also see client-side input filters in browsers. It was huge with JavaScript for a long time. Probably still is. And then, of course, when you mention it, people go, oh, server-side JavaScript. Which continuity. Basically, there's no interruption in the interaction. You go to the grocery store, you want to go check out at the counter, it's full, but they keep putting on new cashiers. So basically, they can handle any volume, and they keep putting in more cashiers as you need to. Okay, door is blocked, they have a secondary door. You can still come in and out. Business service doesn't stop. So we also know this as survivability, load balancing, redundancy. Okay, we want to avoid the single point of failure, which is actually a big deal. As you can notice, it's actually at odds with resilience. Because here you want the services to keep going, and on the other side you want it to fail securely. Non-repudiation, you want to make sure that you know all the actors' roles within an interaction, that they can't deny it. Some people come, some people go. That's nice. Confidentiality, this is the big one. Basically, you're looking at anything that's displayed or exchanged between parties is seen only between them and not outsiders. Yeah, we think we know that, but yet we still call that privacy. When privacy is actually the asset is displayed or exchanged between parties in a way that's only known to them. Okay? So that means you have this, and you've seen this on pretty much every TV movie that deals with bad guys and drug dealers and stuff, is that they know the drug deal is going down, but they have to catch them doing it in the act, and they don't know where the deal is going down. So of course, all of a sudden they just know that famous Miami drug dealer shows up in town, okay? Famous other Belgian drug dealer shows up in town. All of a sudden they both walk away, and one person buys a Lamborghini and the other one, buys a kite. So the problem was privacy. They actually didn't see the interaction happening, so they couldn't prove that it happened. Hence, business you do behind closed doors. Integrity is your control over any undisclosed changes. The only place where I actually see this working really well is with any kind of hashing, MD5 hashing sort of thing, or PKI, which, by the way, is not realistic. And then, of course, alarm. So any kind of notification that safety has failed, circumvented. So you have to wonder, things like IDS alerts. Is it an alarm or is it not? Server logs. If nobody reads them, if they get ignored, is it really an alarm? Okay? And then, of course, you have something different, like home security systems, where if somebody enters a door, there's a little passive infrared thing. And so there you can actually block each access point with an alarm, so that way when it's open in any way, whether it's the lock that's broken or the door that's broken down, or when they come in through a window, the alarm still sounds. Then there's a third part of this, called limitations. And here you have your vulnerabilities, weaknesses, concerns, exposures, anomalies. Yes, we classify it in 5 ways. You'll see the CVEs basically only use vulnerabilities and exposures. We have mapped pretty much one-to-one with the common accepted way of classifying things, but we do it a little different because the normal way of classifying vulnerabilities actually doesn't work. If you've noticed, over the years, people keep rehashing old ideas. There's not been any new research. Our new research that's come out has shown that there are better ways to classify vulnerabilities, yet in order for it to be accepted, it still has to be sort of like the old way so that people don't get confused. And whether or not you want to call it a vulnerability, weakness, or A, B, C, D, E, we don't care. Don't come back to me with the definition. That's not what a vulnerability means. That's what it means to me, buddy. Okay? So basically, you give, deny access, or you hide your assets. That's a vulnerability. A weakness, very simple. You know, you can, pretty much anybody can use this, figure it out. The risk that's involved in that happening, completely different issue, not our problem. We're just doing a metric for security. The weakness actually depends on the Class A controls, the Class B controls for concerns, exposures deals with visibility, and anomalies are anything that's unidentified or unknown that can't be accounted for. Now the beauty behind this is that we don't give it multipliers. We don't say, this one is worth 5 times as much as this one, or this one, which is only worth 1x versus this. That's obscene, biased, old school thinking of eating 4 eggs in the morning a day and a heap of bacon. I mean, that belongs back in the 50s, and that's still what they're selling. Instead, what we said was, based on the controls and the operational security that you actually have in place right now, that's what determines the values that go here. So, this is actually dynamic. How much one vulnerability is worth depends on how many controls, how they work, the controls, because actually you can have a vulnerability in a control itself, or the security that you have in place. So yeah, believe it or not, the value of a limitation actually depends on the security controls you have. What an amazing concept. That's right, I'm the genius who came up with it. I can't believe somebody else didn't come up with it. I think somebody did, they worked for a corporation, they got fired, and nothing ever happened. So if we want to quantify it, basically we have this beautiful sheet at EasyCom. You can download it and use it yourself, so that you don't have to do math. Okay? You just have to count, and most of us can do that. Counting, okay? Real integers. It's fancy. Basically, you count up your visibility, your access, your trust, and then your controls. And when you count these up, dynamically, the values here will be generated. Okay? And all of a sudden here, we see an anomaly is worth nearly as much as a weakness. You'll get this. Depending on the controls you have in place, you can have a weakness or a concern, or even exposure for more than a vulnerability. It can happen because it's dynamic. It's rare, and you have to have some pretty screwed up security to get it, but it happens. So basically, we look at visibility. We found 250 servers, systems, and of them, 412 access points, and 14 of them had trusts from this vector that we can tell. And then we also count up the rest of the parts. Okay? Now the beauty of it here is that 10 controls, those 10 nullify one offset. So for every opening you have, all 10 controls combined is basically the same as having that hole closed. So what that tells you is that you have an open service, okay, telnet, which has no controls except authentication. So basically the value of that hole is 0.9 out of 1. So it's still pretty wide open. SSH offers integrity, encryption, confidentiality, integrity, and authentication. So you're already at 0.7. So it gets even better. Each limitation's value is dependent upon the object and control values. So if we add more controls, it changes them there, in which case your final delta, how much change happens, is influenced. Your delta tells you your security change. So, for example, if this was a network, one network out of two networks, two companies combining, and you already had the other value, you could actually combine the two values, or you could say, this is the change that would happen when we add their network to our network. We can already predict the security change, which I just talked ahead of myself in the slide. Okay, so for some fun and games, we can ask ourselves, we can answer these questions theoretically before we try it. Is one network firewall better than a host firewall in each system? Or does two-factor authentication really make a difference in security? So we can basically look at this and we say, all right, here we have -9, where we have 5 hosts, 5 visible, each with one service. Okay, no controls, because each one has a host-based firewall on it. So we've got a -9 for change in security. A network firewall adds one additional visibility, it's an additional system, and a single point of failure. So it has a new weakness. And we've got -15. What do you think people are doing out there in the corporate world? We know what they do. They do the single firewall because it's easier to administrate, which isn't actually true if the administrators actually did their jobs. How many administrators here? How many? How many of you are lazy? Keep your hands up. All right. Just go for the coffee, right? Okay, one-factor authentication. -7.9, where you have 4 or 5 systems, each with one service open. One of those has only one of those services has an authentication. So we have -7.9. And if you add an additional authentication to that service, you're at -7.2. So it makes a slight bit of difference. But two-factor authentication also means a huge cost, because you're talking about tokens and all sorts of new tricks. Okay? So you can actually then see if it justifies the cost. I'm almost done here, people. Now your party tricks, because you're all so nice to me, okay? These are fun. You go to an attractive guest in the party, and you explain to them which room is more secure, the living room or the bedroom. Huh? And they should go with you. Come on, you can do it in your head. You can calculate OPSEC, visibility, access, trust, just count the windows, the doors, how they open. It's a great trick. Some of you are going to try it, I know it. You explain to the host exactly how secure the silverware cabinet is, and then you test it. Huh? Tricks for dear friends. Then when the police come to the house, okay, and they explain to the fine officers, you can tell them exactly, precisely the security metrics that just because the house is rocking, that it's still very safe. And they'll just go away. Because they can't do science, except the forensics guys, I guess. This is the other police. Okay. To wrap it up, some keys to proper security testing according to the FOSDEM. Using a scientific method. Transparency. Tell them what you didn't do as much as you did do. You don't rely on pattern matching, meaning just because your experience says that the router didn't respond to that ICMP packet doesn't mean that that's always the case. Your intuition is a weakness in a scientific methodology, meaning what you think works, or what your gut feeling is probably statistically wrong. And you won't know that unless you actually try it and do the test. And if you're consistently right all the time, which some developers sometimes are, but they're like one gene away from being a robot anyways. You want to be very formal in your verification process. That means you actually test it formally and not just cut corners. You want to recognize when something is in a hostile environment, meaning that you're going to have a lot of interactivity that you did not cause. Yes, when you test things on the internet, other people on the internet might be going to those servers at the same time. That's right, it's dynamic. Some of us forget that. And common criteria is a good place to start when you're trying to figure out things about systems. But since people get to make up their own criteria before it goes into it, it's not always correct. But it does give you some good ideas. Like, for example, Microsoft, we know, is not designed for hostile environments. And they know that, and they admit that. Yet, legally, they can sell IAS server that goes with it. They can package internet utilities, internet applications, for a product that they knowingly know cannot be in a hostile environment. And I say Microsoft, but it also includes a lot of Linuxes too. Okay? So, keep that in mind. Quick thing about OSCP certification, if you're interested, basically these are the walk-the-walk things. Even if you guys don't want to take it, you might want to consider hiring somebody who is. If you're looking for somebody who knows security, it's pretty much a standard for if you want to hire somebody and you want to make sure that they actually know what they say they know. This is a good fundamental. Okay, if you're looking for a good security person who can actually think and develop tests on the job. Okay, no robots. So we have the analyst, we have the tester. Okay. Any questions, any information? Anything? You first. Yes. Wait, of the what? Does the CVSS fit into the OSDEM? How does it work? Sure, anything can be integrated into the OSDEM in that way. I don't particularly think it works, but that's my opinion. I haven't done thorough testing on it, but I think it's very biased. And in a security task where you try to say something about operations in a factual manner, to integrate something biased into it, where you don't specifically say in the report or to the client that it's biased, you are lying. Yes? That's where you find limitations within the authentication scheme. Sorry. The question was, do video up there. What happens with the strength of a password or the existence of a password in an authentication scheme? Do we just count, or is there any kind of weighting to it? And the point is that there is no weighting. It's just you do test it. And if you find vulnerabilities or weaknesses or concerns in the authentication scheme itself, then that also counts against it. Does that make sense? You're still testing the controls. Controls you can have, for instance, you can have antivirus, but antivirus is just a blacklist, and your tests are going to find that it has lots of weaknesses. Depends how good the password is and how bad the token is. That's why you test it. Okay, I think we're out of time here almost. Anything else? Anybody else? Well, he says we're not. So easy questions now. Only easy questions. Favorite color? Favorite animal? Unicorn? Just kidding. Come on. Nobody? Now all these hands. Can I explain why I don't talk about risk? Risk is biased, and it's different for everybody. So, for example, maybe the thrill of jumping out of an airplane
is worth the plunge 10,000 feet to your death because you really like it, okay? It's a different thrill for me. It's very biased. So we would have a different risk weighting system towards something like that. The FOSDEM itself is a platform for risk. So you do the metrics, you actually have a foundation that's solid, then you add your risk. Then you can say, well, this vulnerability is used a lot, or we see this in the wild, or any of the opinion you want that goes in your summary or your report. But at least have the foundation of knowing what's even there first. Somebody else? Yes? Who? As a matter of fact, I do know that certain governments do. We find it in Switzerland, Germany, Mexico. I do know that the United States Treasury Department recognizes it, I guess you could say. We train a lot of people, a lot of departments. Not that many I hear from. They don't have to tell me if they use it. But I only hear secondhand. So I can only say on the side who talked to me or who told me. For example, my biggest one I was talking about yesterday was that I heard from NASA Ames Research. And for me, that's like the geek mecca, you know? Those are rocket scientists. So for all those people who hate me, that's okay because, you know, I got NASA. But yeah, they don't have to tell me. Or it's nice if they do, but I don't know. But I think it is pretty much prevalent. I keep hearing of places. That's it? Okay, I gotta catch a cab and catch a flight back to Barcelona where it's warm. So.